Look at me. I'm making notes and recording.
Just in case it becomes a bit muffled. But I know, like, this record is quite good. It's over there.
I don't think Archie isn't in today.
But she talks really quietly. She talks really quietly.
Sorry, I have a Samsung.
Yeah, I think so. The back there, couldn't I, actually?
Right, lads,
That's easy.
carefully, Miss Draken's at the bench, you can take your chairs and go and sit round.
I think it was before Christmas, wasn't it?
Yeah.
You did a practice? Right, so this is the same procedure, precisely, but obviously it's a different input variable. Do you remember what the
concentration of yeast.
concentration of yeast. Right, well obviously it's not going to be that one. I'm not at liberty to tell you which one it is, but...
Hint.
Oh no, I'm not giving him, but I'm just saying there aren't that many possibilities, are there?
Temperature.
There are very few possibilities, that's one of them. Right, okay. Do you remember how you did it?
Yeah.
You did?
Yeah.
No? Can you remember doing it?
Yeah.
Oh, that's a relief.
The time taken for colour.
Yeah, so you just, you've
like
got
colour
a yeast suspension, don't forget it's a suspension, and methylene blue.
Artificial hydrogen.
Sorry?
Artificial hydrogen.
Yes. Yeah, I'll put hydrogen at a second. Right. Now then, the amounts that we used were 10 mils of yeast suspension and very small amount of methylene blue each time. It was 0.1 of a milliliter. I know I should say. Pipette.
What's she doing here? She's doing the demonstration of the... I know, but what is her IV? Infinite variable, probably... I can't really see from that. She'll tell us in the... It won't be temperature, because there's no water drops around us.
This is a 1 ml pipette, which you use on the filler, and the quantity of methylene blue you'll use each time is one of those. Okay, so that's 0.1. Now, if you remember, the sensible thing we did last time was to do all the tubes of methylene blue first, rather than doing them better than one at a time as you need them. There's no harm to be. There's no harm in setting all those up at the beginning. So your range has got to be at least 5. Don't forget, 5 is the minimum number, not the maximum number. So if you've got time and inclination, you can do more than 5 in your range. Okay? Because there will be the possibility to do more than 5 if you so wish. So I'll give you the methylene blue in a little bottle. I think it's probably the best way to supply it to you. Right, so I filled it to precisely one of those marks. And I'm not going to do empty. I'll do a couple. That's empty, isn't it? And you should have good control over these. There we are, that's one. Okay. So you're delivering 0.1 each time, right, and so on. I don't particularly want to do any more. But I'm only going to show you, I'll remind you how to do this, so I'm going to put that back. And then you can put that down on a piece of paper, please, don't put it on the table because this stuff stains like billio. And then you're done with that. Now then, 10 ml of the yeast suspension each time. Now here's a suspension, so before you take your 10 ml sample each time, it is important to stir it. Okay, so you get a sort of homogenised sample each time. Otherwise, some of the yeast will tend to settle in the bottom. Okay, so before taking it each time, give it a little stir, and then extract your 10 mils. All right. Now, can you remember what else we need to do apart from just that? We know that we're going to mix the two of those together, and the colour will change.
We need a reference point.
We need a reference. Yes, we do indeed. So we need a second tube of yeast. Quantity doesn't really matter in this case because, as I say, it's only a colour reference. You can mark your tube R so you don't get it mixed up if you like. Okay. So this is our water bath. I have no idea what the temperature is. It's warmish. Let's have a look. Now then, that's reading 33 and a half. Now, equilibration. You can leave that in there for several minutes, but you may find, you're looking at the temperature of the beaker, of the water in the beaker. But even though it's been there after several minutes, if you then put the probe, the temperature probe, into the test tube, you'll usually find that it's at least 2 degrees lower. So it's up to you if it's this you want to measure, and that temperature that you record as your operating temperature. Because if we went ahead now, and I take the data and I write 33.3. It was 33.3. It might be accurate or it might not. But it might be a better idea after a period of equilibration to record the actual temperature of your reactants. There we are. That's 30.6.
3 degrees.
But it's up to you. Okay. If you were doing temperature, it doesn't matter. It doesn't have to be, exactly 30, 35, 40, 45. Because if you're doing your own temperature, making your own temperature, then it's very difficult, especially using something like this, to get it exactly right. You can aim for temperature. I want this one to be 45. So you try and get this 45, perhaps a little bit higher, and then and this comes out at say 43 or 46, and it's stabilised at that temperature. And you think, right, well that's my operating temperature, and it doesn't really matter. There don't have to be perfect numbers on the x-axis, as long as you plot those numbers accurately. You plot 36, not 35. 41, not 40. If that's what it turns out to be, you know that, don't you? That's a way of making it easy for yourself. So that's why I'm going to. Well, there we are. That's now saying 32. I'm equilibrating this tube as well, even though it's a really tiny, tiny amount. Now, obviously, that's take no time at all to get up to temperature. The most important thing is, can you remember why the advantage of putting this tube in there?
Because when you're mixing them,
because we're going to put the yeast into that one, because it will mix more effectively. If you just try and dribble that tiny amount into there, it takes a while to mix it thoroughly, to get one colour. And of course, as soon as you do mix it, don't forget the reaction is starting. You can't say, right, I'm ready now, start reaction. Because as soon as you put those two things together, the reaction is starting. So you have to try and mix them as quickly as possible before you press your timer. But it is equally important that you do mix them thoroughly and you get a nice even colour. Because if the colour is uneven at the beginning, if it's patchy, you've got some blue areas and you've got some paler beigey areas. When the colour of the yeast returns, i.e. the blue colour disappears, that will do so unevenly, and you'll be looking at you thinking, is that? Oh no, there's a bit of blue, there's a blue bit there. So it needs to be a nice even colour at the beginning, so that you get a nice even colour at the end, and it is easier to determine the end point. All right. This is all common sense stuff, but I mean it doesn't do any harm to point it out.
When we add the two together, should we use a rod to stir?
Yes. You'll have to use a glass rod as well. Can we do this at the end, please? Right. 32.8. Somebody wants to make a note of that. I'll take that out of there in a minute. Yeah.
When you mix the two together, do you use the rod to stir it straight away?
Yes, I will. So I'm going to pour this into this. Okay. Right. Colour standard. I put it side by side. Yeah, I think I got that nice and even. Now, a very good tip when you do any investigation is as you actually do it, as you're physically doing this, as opposed to just thinking about it in your head and planning it, there will be certain shortcomings in the procedure, limitations and so on, that will only occur to you because you're actually doing it. Because I do, and then as you do them, jot them down, because things will occur to you as you're doing. You say, well, that's not very satisfactory, is it? It may be something you can do something about. It may not. But it's a very good idea to make a note of them, to scribble them down at the time, because when you come to do your write-up, you will find these things very useful. When you come to do it, you might not remember these little incidental things otherwise. They might slip your mind. So if you just jot them down as they occur to you, when you're going through the procedure, something strikes you as less than satisfactory about it. That information might help you when you're doing you're talking about your analysis, you're talking about evaluation and improvements and so on. Okay. Mm-hmm. Yes,
Say if our independent variable was temperature, do you leave both of them to equilibrate? Say you're treating at 30 degrees, you leave both to equilibrate at 30 degrees, and
both what?
the methylene blue and the yeast
Yes,
suspension.
yes. Yeah, we were equilibrating both the methylene blue and the yeast. Not the control, obviously. It doesn't matter a jot what temperature that is. Now you can see, I can lift it up, the importance of having the control. Because without the control, you think, that's fine, that's gone back to normal. But when you compare them, no, it hasn't, not quite. Don't encourage you to take them out and look at them. You can. It's better to. I reckon that's there now. 243. Don't forget, there'll always be a blue collar at the top there, so ignore that, okay? Because that won't disappear, all right? That will remain. So ignore the blue collar. Yeah. Again, the end point is somewhat subjective. It helps having the colour standard, but I mean it's not, it's not perfect. When you look at it, you think, perhaps it's changed. Perhaps it was still a tad darker. Again, that's not a perfect way of doing it, as I say, because it's very subjective. Make a note of that. Okay. So that is it, really. Can't think of anything else. Questions?
If the
Go on, Aaron.
Say we do the temperature, how would we get the right temperature that we wanted to? I mean, would we use water baths or would we use kettles and stuff?
Well, you know perfectly well that if you're going to do a temperature investigation on something like this, you're not going to be given thermostatically controlled water baths. You'd have to juggle with it yourself. But everything you need will be laid on. Don't worry.
So the reference point is just a tissue of heat, pretty much.
Oh yes, yeah.
If the independent variable is pH, we haven't used buffer solutions before. So how would that work in terms of regulating different pH?
We use them in our BY3.
Yes, you did. Yes, you did. That's not a problem. Everything you need. And any additional instructions you need, as far as quantities of buffer or whatever, will be given to you. Okay, so you won't be left wondering, well, how do we go about doing this? So don't worry. Everything you need will be there, available for you, and any information additional information that you need will also be available for you in order for you to do the procedure.
If you were to use a buffer, would you add it after you mix the methylene blue and the yeast, or just to the methylene blue, or just to the yeast?
I'd tell you. I think we can give you that information. No, there's not anything else I need to tell you. Yeah, so again, think about the range. If we were to give you a pH, I wouldn't just give you 5 pHs. So would you take in the lowest and the highest, or ones in between, or would you concentrate on that end, or concentrate at this end? And again with temperature, think about the temperature. Right. I mean, and you want to think of, and also think of something that's going to work. I mean. Would you want to do too many temperatures that are very cold, because of the time element for one thing. All right, and you think about denaturation, and again, the number in your range. 5 is the minimum, not the maximum. I'm not sure you get any more marks for that, as long as you can have 5. But the more data you have, it's bound to be to your advantage.
You said start the timer once you mix it and put it
Once you're satisfied that it is thoroughly mixed, okay, because if you don't mix it thoroughly, so I can try. I can show you if we try and do this the other way around. Right. You see, you can see at once the problem is half it's gone down the tube, and before I start mixing it, can you see how much more efficient it is to add the yeast to the methylene blue? So don't forget to do it that way around. Because all the time I'm doing this, the reaction is starting. So then you think, well, that's fine. Your start point is a bit blunt, really, But that is a nice even colour. Because if it's not an even colour, as I say, it still works. It still goes back to this, but very patchily. So you're looking at it and you're thinking, well, is it gone, or is it not? Because there's blue bits and there's beigey bits. So.
You must be thinking about your dependent variables, independent variables, control variables when you're doing this. And when you come to a write-up, you need to say exactly independent, or my independent variable is da-da-da-da, my dependent variable is da-da-da-da, and the units that you're going to use to measure it as well. Yeah? So if you need to say the independent variable units. Also, you need to be thinking about the limitations. Clearly, from looking at this right now, you should be able to start thinking about the limitations of this experiment. Because the one you will be doing will be very similar to this.
When do we find out the IB? Friday? So right. So when you get
That will be.
You just do the use concentration.
That's when you write the
Use concentration.
right?
Yeah, that's the temperature of the
But it will be very, very similar to this.
No, what you on?
So it should be quite simple
Use concentration.
to figure that
I
out.
mean, you can think about it.